Hi everyone, welcome to Pre-Calculus Lesson 7-4, Basic Trigonometric Equations. So we're going to start out by looking at the basics of what it means to have a trig equation and then what it means to solve them. So basically a trig equation is basically an equation that has a trig function in it. So it's going to be some sort of an equation that has like sine, cosine, or tangent in it. And the variable that you're solving for is generally going to be the angle in the trig function. Now, how do you solve this? You start off by isolating the trig expression. Then you're going to use inverse trig functions to find the angle measure that's going to make it true. Now, generally, for most trig functions, you're going to have two answers. But depending upon how they word the question, your answer could look different. So if they ask you from 0 to 360 or 0 to 2 pi, you're just going to give two angle measures. But if they ask for all of the answers, with sine and cosine, you're going to take the two angle measures you just got and add 2k pi to it because that's a full circle and it's adding on full circles. K is just a variable that represents a counting number. And then for tangent, you're only going to get one angle measure and you're just going to add k pi to it because tangent's period is pi. So this will be more apparent when we go over some questions, so I'm hoping that that will make it more clear as to what I'm talking about there. So let's just take a look at some examples now. In example 1, we need to solve the equation sine theta equals 1/2. So notice our trig function is already alone. So all I need to do is use an inverse trig function on both sides of this to get theta alone. That would look like this. Theta equals sine inverse of 1/2. Now we're going to use our unit circle to find out the inverse sine of 1/2. So I'm looking on my unit circle for any place where the sine value, the y value, is going to be 1/2. And I notice it here at pi over 6, so that's one of my answers. But there's another place over here at 5 pi over 6. Now notice that this isn't plus pi. Pi would take you down to here. It would take you to 7 pi over 6. So that's why with sine and cosine, we don't always do plus k pi. Because what we're going to have is, for the general answer for this, I can have pi over 6. And then if I add on a whole 2 pi, it's going to take me all the way around the circle back to pi over 6. But it's going to be an angle that's equivalent to it. Okay, so that's why we use those equations. So when we do this, here it is, we're going to have theta equals pi over 6 and 5 pi over 6. So that if they asked for it just between 0 and 2 pi, these would be our two answers. But they didn't ask for that. They said solve the equation. So we need to give the general answers. Pi over 6 plus 2k pi and 5 pi over 6 plus 2k pi. And these are the two equations that will get you an infinite number of answers for this equation. So let's take a look at another example of this. In example 2, it says solve the equation cosine theta equals negative square root 2 over 2 and list 8 specific solutions. So you would start out by doing the inverse cosine on both sides. So inverse cosine of negative square root 2 over 2 comes out to be, from our unit circle, we need a negative, so pi over 4 is close, but it's really 3 pi over 4 is the first place we have a negative cosine value, and then it happens again at 5 pi over 4. So now, for your final answer, all we're going to do is write those as equations. Theta equals 3 pi over 4 plus 2k pi, and 5 pi over 4 plus 2k pi. Now, it's tempting to be done there, but they said list 8 specific solutions. So what I did to get these solutions is I started off by putting a 1 in for k. So I wrote 3 pi over 4 and 5 pi over 4. Now if k is 1, I would just do 3 pi over 4 plus 2 pi. That comes out to be 11 pi over 4. Then I did 5 pi over 4 plus 2 pi, which is 13 pi over 4. Then I went to 2. I put in a 2 here. So I got 3 pi over 4 plus 4 pi. And that comes out to this 19 pi over 4. 5 pi over 4 plus 4 pi comes out to be 21 over 4. 21 pi over 4. Then I did 3 in for this, and I got these two values here. And I just got common denominators and added my fractions together. So these are the 8 solutions they asked for. Let's take a look at a slightly different example. This is going to be an example where the angle that they give, or the result, is not on the unit circle. So whenever they give something like this, the equation cosine theta equals 0.65, we're going for things that are not actually on the unit circle. So that means that we have to use our calculators to get this answer. Now, generally, we're going to be working in radian mode, so you want to make sure your calculator is in radian mode. And we're just going to do the inverse cosine of 0.65. Okay, so inverse cosine of 0.65 is 0.86 or so. Now, I rounded to 2 decimal places because they were rounding to 2 decimal places. But if you get your rounding off and maybe you go to 3, I'm not going to worry about that. It's really about getting this angle measure. Now, remember, cosine can have 2 possible answers on our unit circle. Okay, this is a positive value for cosine. The places where cosine is positive is quadrant 1 and quadrant 4. So I need a quadrant 4 angle that would also have the same cosine. So I'm going to subtract with 2 pi. And we do this because cosine has the period of 2 pi. Cosine inverse is defined for the top half of our unit circle. The second solution is going to be in the bottom half, in that 4th quadrant. So 2 pi minus 0.86, again, I used a calculator. You get 5.42. Last, we finally just have to add on the 2k pi's that we need for our final solution. So it's 0.86 plus 2k pi and 5.42 plus 2k pi. So let's take a look at an equation where we have tangent. We've done sine and cosine. Tangent is slightly different. So with tangent, we have the equation tangent theta equals 2. So all we're going to do is do an inverse tangent on both sides. Now, in a unit circle, tangent does not equal 2. You could have a tangent of square root 3. You can have a tangent of 1. You can have undefined. You can even have square root 3 over 3, or all of those things being negative. But we don't have tangent of 2. So again, this is going to go into our calculator. In a calculator, I found out tangent inverse of 2 is 1.12. Now, remember, for tangent, we're not looking at a full unit circle. When you do inverse tangent, it's only defined from negative pi over 2 to positive pi over 2. Then you just add on k pi. Adding on 180 degrees will get you the same value. So I don't have to worry about getting that second angle measure, and tangent is the one where you don't have to worry. So it's kind of better. I like doing tangent. So we only have that one solution in that range. And all I have to do for my final answer is just do that angle that I got in radians plus k pi. That's the answer for example 4. Okay, now we're going to go on to some slightly harder ones. These were all solved for our trig function. In these slightly harder ones, we're going to need to solve for the trig function. So here's our first harder question. In example 5, it says, find all solutions of the equation 2 sine theta minus 1 equals 0. So this is just like the equation 2x minus 1 equals 0, and we're just solving for x. So I'm going to start by getting this sine theta alone. Now remember, the sine and the theta are stuck together. You can't separate them, but I can get these other numbers to the other side. So when I do that, I would I'd add 1 on both sides, and then I would divide by 2. So sine theta is 1/2. And now I can go back to my unit circle and find all of the places where sine is 1/2. And I can do inverse sine of 1/2. And that gets me pi over 6 and 5 pi over 6. Now it says all solutions, so that means I write those equations. Pi over 6 plus k pi and 5 pi over 6 plus k pi. And those are my answers there. Okay, so pi over 6 plus 2k pi and 5 pi over 6 plus 2k pi. And the way I remember the difference between 2k pi and k pi is that sine and cosine have a domain of 2 pi. That's their period there. So what I can do is I can just remember that sine and cosine have a period of 2 pi and just put a k on it. And for tangent, that period is just pi. So I just put a k on it. So k pi or 2k pi. And it's all based off of those period values. So let's take a look at one last example for this video. It says find all solutions of the equation tangent squared theta minus 3 equals 0. So again, I'm going to solve for tangent theta. Now, just be careful. This squared is not really attached to this. We can get rid of that squared. This is like x squared minus 3 equals 0. That's what this is really saying. So we're going to start off by solving for this tangent theta. So I would add 3 and then do a square root. When you do the square root, don't forget the plus or minus sign. That's the most common mistake I see on this question. You did the square root, it needs a plus or minus sign. So that means I have to find where tangent theta is positive square root 3 and where tangent theta is negative square root 3. And I'm going to use a unit circle to do that. In the unit circle, we find out that pi over 3 has the positive square root 3 tangent, and negative pi over 3 has the negative square root 3 tangent. And I use the negative pi over 3 instead of negative 5 pi over 3 simply because that is the domain for the range for the inverse tangent function. Inverse tangent is negative pi over 2 to positive pi over 2. So now the last thing I need to do is just write these in terms of an equation because it says find all solutions. So I'm just going to take both of these and add on k pi to them, and that's going to be my final answer. Pi over 3 plus k pi and negative pi over 3 plus k pi. Okay, so that's the basics of solving equations that are trig equations. Now, next class, we're going to be talking about some of the harder things that we need to do, such as factoring or using some of our other formulas to help us replace things and then solve for theta. So make sure you let me know if you have any questions about this lesson, and I will see you soon.